Here are the objectives of this lecture that we will discuss the goals and principles of protection in modern computer system. Similarly, we will explain how protection domains combined with an access matrix and used to specify the resources a process may access, and then onward examine capability and language-based protection as well. So here are the goals of protection, and the first goal is that the operating system actually consists of many objects, and there may be the hardware and the software. So how these objects will communicate with one another, and similarly how they will share different functions with one another. Here you can see that each object has a unique name and can access through a well-defined set of operations. However, there is a problem of protection, and that is that the objects should ensure that they access every function or every program correctly without any error. And similarly, the authentic or the authorized object should access that specific program. Here are the guiding principles, the principle of least privilege. And you know about that the privileged objects have access to almost all functions or all files of the system. You can see that the programs we have certain, let me explain over here that protection. So here are the objects, for example, object 1, object 2, object 3, and here we have files, and there are some big programs in which certain functions are mentioned over here. So this is program P1, this is P2, this is P3, and here you can see this is 3.1, 3.2, 3.3, and over here this one is P4. So you have 4.1, 4.2, 4.3, and 4.4. So either this object would be able to access program 1 and program 3, and you will further specify that it can have access to program 1 and then onward in program 3 to 3.1 and to program 3.2. It is not necessary that you will have access to all those functions which are available, or all those uh, child classes. You can see, you can specify it as this is the parent class and this is the children classes. So it means you don't have access to all these information, and that's why it is still a challenge that how to protect 3.3, how to protect a function that is inside program that is 3.3, how to protect function 3.3 from object 1. So that is a very challenging task as well, because you are giving a control to an object to program 3. And similarly, that's what he is explaining over here, that you have instruction, and the instruction is actually a command to a system. Similarly, you have a program. Program is set of instruction. Similarly, you have a software, and a software is set of programs. So look at this. If you have many programs, how you can protect them from each other? How you will protect? And similarly, you have many instructions per program over here, set of instruction. So how to protect every instruction from every other instruction? So that is the important challenge that you face in a distributed system. So look at this. Program, users, and system should be given just enough privilege to perform their task. It doesn't mean that you will provide 100% access to every program, to every user. And as you know, similarly, in Windows operating system, you can create users and you can give them access based on their role, based on their task assigned to them by the administrator. There is separate policy from mechanism, and the mechanism that the stuff built into the operating system to make protection works. And the policy can be the data that says who can do what to whom. So it means that who can update your file, who can execute them, who can copy them, who can modify them, who can delete them, and who can further means create more files. So that is actually the main mechanism behind this approach. You can see over here that we have different domains, and these domains are actually as you have the logins inside your computer. For example, you have an administrator login credentials, you have the login details, and you can log into a system as an administrator. So look at this. Over here in D1, that is domain 1, he has the right of administrator, and he can do everything over here. Look at this. He can read, he can write, he can execute over here. But in this administrator domain, you can see the objects are different. You have access to object 1, you have access to object 2, you have access to object 3. And based on usability or access to these objects, your access is defined. You can see over here in the first line that access right is equal to object name and right set. What is the object name and what operation you can perform on that, what rights you have once you have access to this object, where right set is a subset of all valid operation that can be performed on the object. And similarly, the domain is equal to the set of access right over here. So in this diagram, you can see we have three domains, D1, D2, and D3. In D1, we have three objects, object 1, object 2, object 3. Look at this, with object 1, we can do the read and write operation. With object 2, we can do the execute operation. And with object 3, we can do the read and write operation. Similarly, if you come to domain 2, they have object 4 as well. Beside object 1, 2 and 3, they also have the object 4 over here, and they both are sharing this object. So this object is actually object 4, which give you access to print. So you can print anything. Similarly, you can see in domain 2, you have access to object 2 and object 4. You cannot read anything, but you can write. You cannot execute anything, but you can print. And similarly, in domain 3, you have access to print, you have access to execute, you have access to read, but you don't have any access to print command. Similarly, you can see over here the example of Unix, where domain implementation is done with two different domains. The system actually consists of two domains, as we have the user and we have the supervisor. And we have also studied that there are two domains in Windows operating system as well, that either you are in kernel domain or you are in user domain. So here he is using the user domain and the supervisor domain. So domain is actually the user ID, where each file has associated with it a domain bit that is called pseudo bit. When file is executed and setUD is on, then user ID is set to honor of the file being executed. When execution completes, the user ID is reset. So it means they have to reset the ID again for the new utilization of that file. Here you can see the domain implementation over here, that let D, which is a big domain, DI and DG be any two domain rings. If J is less than I, it means DI is subset or equal to DJ. And here you can see in this diagram as well that this D is actually this complete circle. And within this circle, ring 0 is, for example, DI, ring 1 is, for example, DJ, and the remaining part is over there you can have. So D is actually a big set, and DI and DJ are actually the subsets of D by itself. So you may have multiple subdomains in a top domain. Here the access metric is also given over here, which explain the protection of processes from each other. In this access matrix, as you know about the graph, that rows will represent the domain, while column will represent the objects. Here is this access matrix. You can see over here that you have the objects and you have the domain. I think we are recording this lecture. It's already started. Yeah, so objects and domains are given over here. You can see that what object you have. So you have the objects F1, F2, and F3. And similarly, the fourth object is the printer object. While in domains, we have D1, we have D2, we have D3, and we have D4. So in domain 1, we have access to object F1 and object F3. And with these two objects, we can only perform the read operation. In domain 2, we have access to the print object only, and we can only print in D2. So look at this, the access to the printer is only given in D2. And there is no other domain in which you can access the printer. So whenever you want to print, you must go to the domain 2. In third option, you have D3, where you have a read operation with object F2 and you have execute operation with object F3. While in domain 4, you can do read and write operation with object F1 and you can do read and write operation with F3. So look at this, it depends on the domains, in which domain you are, and similarly to which object you have access. So these are actually the privileges every object have, and similarly in every domain you have. If a process in domain DI tries to do operation on object OJ, then operation must be in the access matrix. And as you know about from the last slide, that you must have, look at this, you cannot do print with the F3 in any domain. You cannot do print or execute with F2. You cannot do it with F1 as well. You cannot execute, you cannot print anything with F1 and with F2, but you can execute with F3. So similarly, that's what he is saying. If the access metric don't have that particular operation specified for that domain or that object, you cannot perform that. Similarly, you can expand to dynamic protection as well. You can, we have a question in dynamic routing as well, that you can change it as per condition. So similarly, as the system is dynamic, so the new queries, the new requests, the new demands raises with time as the system matured. So similarly, the dynamic protection should be adopted over here in this situation. Over here you can see that the operation to aid, delete, access right as well. So in dynamic operation, you can add any right to someone, you can delete them for security purpose. So you have a full access to this access matrix. The special access should be given to, as I told you earlier, that let me explain it here on a whiteboard again. As I told you earlier, that for any particular file or for any particular domain, you have these commands. You can create, you can read, you can write, you can execute, you can delete, and you can further add, you can copy as well. So look at this, either you have all these commands in D1, but for example, if we can see that in D0, where honor is involved, honors have right, all these rights. So you can give these rights to an honor. But for other users, you have different criteria. For example, if you have a system admin, then the system admin may have the maximum right over here. You may give him all these rights to the admin. To a simple user, you can only give the rights of read and the right of write. So from user to user, the access metric varies based on his role. What is the role of that user? You can differentiate, you can provide access. So look at this, honor of that specific file, OI. Copy operation from OI to OJ. You can copy from one domain to another domain, from one place to another place. Control DI can modify DJ access right. So look at this, as an administrator, you can change the access right for DJ, for domain J. Similarly, transfer, switch from domain DI to DJ. As I told you in that last slide, that you should switch from domain 1 to domain 2 for printing purpose, or from domain 3 to domain 2, or domain 4 to domain 2 for printing purpose, because printing is not available anywhere except domain 2. Access metric design separates mechanism from policy. So here you can see that operating system provide access metric plus rules as well. So for example, if you are providing access of read and write, and any other object is requesting the same file for read or write operation, then what kind of rule will be applied over here? And we already discussed this in cache consistency problem as well, that there will be certain locking protocol based on which you can stop some users, that they can only read but they cannot
Sir,
write, or they
after
can modify. Yeah, is there anything? It ensures that the metric is only manipulated by authorized agent, and that rules are strictly enforced. So anyone would not be able to access those access metric or modify or manipulate them. Only the owner or the administrator or the co-owner, you can see, can change. As we had discussion about the meeting, that host and co-host we have in this meeting, my laptop is actually the host, while my iPad is actually the co-host. And that's what I'm writing with the pen is on my iPad. So we have the authorized user as well, that you can give some rights. As for example, I can give you some rights here in this meeting as well, that you can change your name, you can start recording, you can invite people, you can accept people from waiting room as well, and let them in to join this meeting. So you can do all those operations once the administrator or the owner of the object or domain or program allow you. Similarly, the policy where user are dictated. As I told you that you can give a read and write operation, a write operation or execute operation to a single object at the same time. So both objects cannot perform the execute operation at the same time, or both of them may not update that file at the same time. Who can access what object and in what mode? So look at this. These modes are either you are in the reading mode, either you are in the writing mode, or you are in the execution mode. So here you can see in this implementation that each column will represent the access control list for one object and define who can perform what operation. So as discussed earlier, in domain 1, you can perform read and write operation. In domain 2, you can perform the read operation. And similarly, in domain 3, you can perform the read operation, while each row will explain the capabilities of this system, and the capabilities, that what capabilities they have for each domain, what operation allowed on which object. And here you can see that with object 1 you can perform the read operation, while with object 2, while with object 4 you can perform the read, the write, and the execute operation. And similarly, the object 5 can perform 4 operations. He can read, he can write, he can delete, and he can copy as well. So you can copy it from one place to another place with the help of object 5. Here in this bigger diagram, you can see over here that we have now a switching mechanism as well, that you can jump from one place to another place, from one domain to another domain. We have again the same four objects, F1, F2, F3, and printer, and we have the same domain D1, D2, D3, and D4. And we almost have the same right. You can only do printing in D2, print. But look at this, what they have written over here, that you can switch. You can switch over here in D2. So there is a switching mechanism from D1 to D2, and over here, once you switch, so you can have access to print object over here. So you can print and move from D1. So you can see over here, while you are in domain 1, still you have indirect access to printer, not direct access. But you have an indirect access to printer by switching to D2 and do the command of printer, and then come back to do the read operations. While over here, you can see in domain 2, you can switch to domain 3 and you can switch to domain 4. But in domain 3, you can see that there is no switching. You can switch from domain 2 to domain 3, but you can't switch from domain 3 to domain 2. But over here in D4, you have access to D1, that you can switch to D1. 4 can switch to D1, and you can access all those objects which are available in domain D1. This is further divided to explain the copyrights in these access matrix, and you can see again over here with the further explanation he has given in these two tables, that is table A and table 2. In table A, he has object F1, F2, and F3, and domains again D1, D2, and D3. With F1, you can have access to execute operations. F1 object have access in all domains, while in F2, you have only the read operation in domain 2 with object F2. While object F3, you have the read and you have the write operation. Similarly, in table 2, you can see you have again the three objects and three domains, and over here they have added only the read operation over here in domain 3 with object F2. So now you can access object F2 with you can perform the read operation with object F2 in domain D3. In next diagram, you can see over here, again, they have changed the honor execute. So look at this, the honor execute is mean that you have access to all functions, all instructions, all programs that lies in domain D1, and you are giving it to F1. So that's why most of the time hackers want to get access to that particular object which have the rights of honor. So it means once you have means the accessibility or the capabilities or the control or the access to that particular object which have the honor rights, you can perform all operations that honor can do with your system. And sometime you can see that there is some protection mechanism. If you want to change your password, for example your Gmail, your email, or your chat software password, then the system will ask you that first give the system password, and once you give the correct password, then it will allow you to change your email password. Though you are logging into the system, but still this is the internal protection mechanism inside this new operating system, that it will ask for the system password. Whenever, sometimes there are many passwords which are saved inside your system for your different emails account, or for your bank, online banking, or for any other online systems. and it's not visible. These passwords are simply hidden, and on the password means window, you will only see the dots or asterisks over there. But if you want to read the password or make it visible, you have to press the I sign. If you press the I sign, it will not show always those password, but the system will ask you that first give the system password, then I will show you that password. So this is the internal protection mechanism followed by many operating systems, that they don't allow you to show, though the system is open and you can do, but they will not give you access, they will not give you the visibility to the confidential or secret information of the user unless and until you don't have access to the system. So that's why they are verifying with the help of system password. In TableDB, you can see over here, they have given the honor, read, and write operation over here. And similarly, in domain 2, you have access to honor, read, write with object F2 and with object F3 as well. So you can have accessibility to those domains with the honor options. So over here you can see the modified access metric of figure B. You have again the same object, you have again the same domain D1, D2, D3 and D4. What access you can do, either you can read, you can write, you can print, you can execute, you can switch over here. Another important thing is added over here, that is the switch control. It means in this domain you can also give the control of switching to any other objects. So that is additional, that now you have given the honor accessibility as a switch, that you can control the switch, either you want to give switching to this particular object in this particular domain or not. So as in last slide, you can see that here it is mentioned that read, honor write, honor read, and write, honor execute. So this is actually related to the switch control. That is a kind of honor switch, that you are giving accessibility to user that they can perform the switching operation. In access control, protection can be applied to non-file resources as well. It's not only to file, but it also can be other resources as well. In Solaris 10, it provides role-based access control to implement least privilege, and privilege is right to execute system call or use an option within a system call. So look at this. What is your role over here? As you know, either you are the chancellor, either you are the provost, either you are the dean, either you are the chair, either you are the faculty member, either you are the staff, either you are the student. So based on your role, you will have certain privileges. The privilege is right to execute system call or use an option within a system call, and it can be assigned to process. Over here, let me explain it, that you have within the UMKC university, you have different roles. And the roles are, for example, you are the chancellor, the provost, the vice provost, you are the dean, you are the chair, you are faculty, you are staff, you are student, you are administration. So look at this, in front of everyone you have to write. Like here you can give control of honor of a university campus. Similarly, OU, honor of university. honor of subcampus. You can see some part of the system. Honor of the faculty. Honor of the faculty or the school. You can see the school. While chairperson is the honor of the department. For faculty, you can see honor of his office and his classroom. Staff can have access to classroom, or they also have access to some offices as well. Similarly, students have only access to class, and even not in the role of honor, not in the role of honor, but in the role of read or in the role of write operation. Similarly, students have access to lab, and students have access to library. And similarly, the admin have access to of honor, to class, to lab, to library, etc. But there is again subsection in admin. Admin of which school? So you can also, for example, School of Electrical Engineering and Computing, School of Social Sciences, School of Education, School of Business. So based on that, this admin belongs to which? So then you can give them access to honor, access to classroom, to the labs, and if they have any specific library in that particular school. So this is the access pattern you can assign to any user based on his role. Okay, this you can user assign roles granting access to privileges and to programs. So you can have access to many other things based on your role. Look at this role-based access in Sun Solaris 10 operating system, user 1, and what is his role? So if he is in role 1, for example, he is the chancellor, then he will have these privileges, privilege 1 and privilege 2. And similarly, execute with role 1 privileges you can process. For example, you can change as a chancellor, as a provost, you can change the admission system, you can change the admission criteria, you can change the entry system, you can give more access to the student and faculty, and similarly, you can change the exams date. So you have these certain privileges based on which you can change or you can improve things. Revocation of access right. For example, you were a faculty member, you were a chair, you were a library assistant, or you have a position of TA in one semester. In next semester, you are not a TA, so you will have no access to any subject of that particular faculty member or teacher. Access list, you can delete access right from access list, and it is very simple, and you can do this operation immediately as you want to. Similarly, the capability list scheme is required to locate capability in the system before capability can be revoked. And you can see over here that you can also have a reacquisition in big pointer as well, that you take the access rights from a user. For example, he was a TA in this semester, and then he is not a TA in next semester in spring. So you will actually revoke all those rights from the user, and in spring 2021 he get the TA position again. So you will again use his credentials with the help of back pointers, and you can assign him the role of TA and give you that access. There are certain capability based systems, and the first one is Hydra, which is a capability based protection system which provides flexibility and fixed set of access rights known and interpreted by the system. In interpretation of user-defined rights performed solely by user program, and system provides access protection for use of these rights. So this is the first example, that is Hydra. The second one is the Cambridge CAP system, that is again based on certain capabilities, and the first one is the data capability, and the second one is the software capabilities, based on which the system can specify that either you would be able to read, write, execute, or you can have the individual's storage or other privileges as well. You can also have a language-based protection as well, and you know about that there is a protection earlier. If you listen about or you worked in assembly language, then you know about it, that how much access you have on the hardware platform. Similarly, some other older languages like COBOL and Fortran also give you access to the hardware level. Specification of protection in a programming language allow the high-level description of policies for the allocation and use of resources as well. The language implementation can provide software for protection enforcement when automatic hardware supported checking is unavailable. And you know about that between modern languages and older languages, there is a difference of additional interpreter, additional compiler is added with these modern languages, which actually helps them to provide access to the hardware. Here is another example he is giving in Java language, where protection is handled by the Java Virtual Machine, JVM. I hope you have learned this JVM while you studied the Java language. This class is assigned a protection domain. When it is loaded by the JVM, the protection domain indicates what operation the class can and cannot perform. So look at this, you have to first define that what kind of operation any class can perform. And you also know about the classes in C and C++ language, and let me explain it over here, that you have different types of the classes. So here you actually declare the variables, and these variables are public, then private, and then protected. And look at this, what you can access with the public, how much accessibility you have with public variables, the access to the private, and similarly with the protected variables. So it is not necessary that a public declared object may have access to everything, or similarly the private. So actually this is also a mechanism used for protection of programs, protection of functions and programs. Another important thing that you are using is that you have always a parent class, and in parent class there is one object which can access everything, which have access to all children classes. And there may be child 1, child 2, child 3, and child 4. So look at this, the parent class object may have access to all of them, but class 4 and 3 may not be able to access. Class 2 and 3, child class, this is actually a child class. Child class 4 to 1, they may not have access to each other. But if you enter or you want to access it from the parent side, then parent side access is allowed by default. But you have special permission if you want to have special permission, or you can say the access right if you want to access child class 3 from 4, child class 2 from 3, child class 1 from 4, child class 4 from 1. So if you want to provide accessibility between these child classes, then you have to perform that specific rights operation. So the protection domain indicates what operation the class can and cannot perform. If a library method is invoked that performs a privileged operation, the stake is inspected to ensure the operation can be performed by the library. So look at this, as we discussed in the last example, that the parent class can access, the parent class object can access to the children class functions. But then onward, you should also know that what about objects within the children classes? Either they will be able to access any other children class or not. And if you want to give access them, then all those accessibilities or the operation will be fully inspected. So that's about today's lectures of protection, that how you can protect different objects, different data items